Good morning, friends. Today we are going to see the next mechanism. In the last two lectures, we talk about the different two mechanism SN1 and the SN2 mechanism. SN1, the name is unimolecular nucleophilic substitution reaction. SN1 is having the two step, whereas SN2 is having the one step, and SN2 means bimolecular nucleophilic substitution reaction. Same way, today we have to focus on the another type of the reaction mechanism, that is nothing but the SNI mechanism. We same way we have to see about this particular SNI mechanism. SNI mechanism stands for internal nucleophilic substitution reaction. As I said, SN1 one for the unimolecular, 2 for the bimolecular, whereas I is for the internal nucleophilic substitution reaction. In this process, part of leaving group attacks the substrate. What happens? Attacks the substrate, detach itself from the rest of leaving group. Example is given to you: conversion of R2-butanol to R2-chlorobutane with SaCl2, that is a thionyl chloride, in non-polar solvent and absence of the base. The product form is with complete retention of configuration. Here in general it is given ROH plus SOCl2, that is a thionyl chloride. Thionyl chloride is used over here. First reaction between this particular two things will be there. Then you will get the intermediate species alkyl chlorosulfate. This alkyl chlorosulfate itself undergoes the reaction where the leaving group will detach itself and which attacks on the substrate R. It will give you the formation of the RCl along with the SO2, that is a sulfur dioxide. Very simple it is. You can see here CrOH plus SOCl2. What happens is R on oxygen, you know the lone pair of electron always there, 2 lone pair of the electron, and there are the oxygen. Here S double bond O Cl Cl. What will happen? This particular oxygen will attack on the sulfur. Okay. Then what will happen? One of the Cl from this particular SOCl will left from that position, and it will go with this particular hydrogen. Here you can see that this OH bond will break, and here this HCl bond will break. Then you will get the alkyl chlorosulfate compound, which undergoes the transition, and it will give you the formation of the intermediate ion pair, okay, which internally undergo the reaction and gives you the formation of RCl plus SO2. Here you can see here what happens. This particular ROHCl double bond O is there, right? But when you take R plus will be there, right? This internally existed. See here, what will happen here? R plus and this minus will be there. Here you can show the O minus charge. Okay, then what will happen is RCl plus acid will form. How it will get formed? This sulfur will give the electron to this chlorine and chlorine will go with this R. It will be the RCl. The left thing will be the SO2. What is meant? Very simple. There is a reduction of configuration. From the same position, OH is leaving and the Cl is attaching. Here the example is given to you CH3, CH2, CHOH, CH2, CH3, CH3, CH2, CHOH, CH3. This is the secondary butyl alcohol, or say you can call it as a 2-butanol. When react with this SOCl2, that is thionyl chloride, it will give you the formation of the first chloronyl, chlorosulfate product. Okay, then this chlorosulfate product will give you the intimate ion pair. How that intimate ion pair will be there? This R group will be there. Okay, having the positive charge, whereas this with oxygen is having the negative charge. Then what will happen? This particular Cl will left from this position, where this electron will give into the sulfur. Sulfur will left as a SO2, and this Cl will attach on this positive carbon. See here, CH plus is shown there. Here the plus sign is there. Okay, you can show on the carbon that plus sign, and where the plus sign is there, at that position that chlorine will goes. Means that's it is the same position from which the OH is left or side detached. When the tertiary amine such as pyridine is added into the reaction of alcohol with the SOCl2, then product form is with inversion of configuration. That is a SN2 mechanism. Such a reaction is known as the Darzon's product. See here, one stereo, that particular compound is taken. Pyridine, in presence of the pyridine, we are going to carry out the same reaction. Here, this OH group is there. Okay. Here you can see the OH group, which hydrogen will break down the Indian oxygen having 2 lone pair of electrons. Here that things is shown. The Cl will left with the hydrogen, and this oxygen will get form the bond is O double bond Cl. Okay. This is the chlorosulfate. The ester is there. This is intermediate. And it will be the pyridine hydrochloride. And that pyridine hydrochloride reacts with this intermediate will give you the product with inversion of configuration. What is the inversion of configuration? Whatever the product will be obtained, it will get OH at the different position. That Cl at the different position means this H will shift to this side and On the position of the edge there will be the Cl. Displacement of the chlorosulfate ester by the Cl via the ascending mechanism. Here it will be the inversion of configuration that you should know. You got this example particularly what happens. One example has been taken. Anybody will tell that? Hydroxycarboxylic acid is there. Phenyl hydroxy ethanoic acid, because two carbons are there. Ethanoic acid or called as CH3 COH. Acetic acid is there. Okay. Very simple it is. You got this particular reaction. What will happen? This bond will break and it will form the bond with this particular SOCl, and it is called as the, we can call it as the intermediate. Along with there will be the pyridine hydrochloride, because whatever the Cl is there, that Cl is attracted by that pyridine, and then there will be the further reaction, displacement reaction will be there in between pyridine hydrochloride and that particular intermediate. They will give you the product with the inversion of the configuration, that you have to remember. Okay. Very simple it is. There are the two examples shown here. First of all, in the direct, when we are not using the pyridine, it will give the product with the retention of configuration. But when we use the pyridine, when we carried out the reaction in presence of the pyridine, at that time there will be the inversion of configuration. There will be the product formation. Product will form with inversion of configuration. Okay. Please go through this particular reaction. It is very simple reaction. There is nothing too much in that particular reaction. Please prepare it well. If you have any problem, any difficulty, you can ask. Very simple, that is a mechanism is there. Okay, you can write in the multiple step also, but it's okay, no problem. Two examples we have seen. One is without that particular pyridine. Okay, pyridine is a tertiary amine given. You can use pyridine or you can't. If you are using the pyridine, then you will get an inversion of configuration. When you are not using the pyridine, it will give the product with retention of configuration. Means from the position, same position, means if OH group is getting lost from the second position, at the same position there will be the attachment of this particular another nucleophilic group nucleophile, that is called as the retention of the configuration. Inversion of configuration means is that it is inverted, the position will be changed. Okay, I think so. It is very easy reaction again. Two examples are given. 2-butyl alcohol, then this phenyl hydroxy ethanoic acid is there. Please go through this particular thing and prepare well. If you are not getting anything, you can freely ask. Very simple it is. Please practice well. When you practice it, then it will become and more easy. Okay. Please make the practice of all these things. Please go through this lecture. If you are not getting, you can ask on the WhatsApp group or set any mode. Very simple reaction that we have seen under the internal substitution, nucleophilic substitution reaction. Okay. here we will stop. Thank you.